Okay, so we're going to look at a quick discussion here about density. And up to this point, we have built a particle model of mass and volume. All right, for example, we know that mass is just the amount of stuff, matter, particles inside of a substance. So we've represented something with, for example, a low bit of mass would be a substance kind of like this, and something with more mass is something with more particles in it. All right. We've talked about how volume is just the amount of space something takes up. So a small box compared to a much bigger box, all right, is taking up more space. All right. Well, we've just finished up the lab with density, and now we need to talk about what density is. Now, technically, density is the amount of mass per unit of volume. All right, and that's a fine definition, but another word that you might want to consider is compactness. All right. How compact the particles are inside of a substance. We've already kind of talked about this when we represented a change in our mass lab. So when we talked about the steel wool in the mass and change lab, we started off with a small compact piece of steel wool that had a given mass. All right, let's say a mass of, let's try that again. We had a mass of, 20 grams. And then we pulled it apart, all right, with a mass of still 20 grams. And we talked about how we could possibly represent this. And what we did was, again, that we had a small thing of steel wool. All right. And then afterwards, all right, if we wanted to represent that, again, we'd still had the same amounts of steel wool, but it was just separated as further apart. That's how we represented that in the first place. Same mass, but different volume. Well, if we look at our definition of density, all right, the amount of mass per unit of volume, all right, both these have the same mass, but this one has a much bigger volume. So, in other words, the compactness has decreased. So this has a higher density or compactness than this one. So let's take a look at another example of density. Now, if we look at what we covered before, we had in our last lab, we had some white blocks and we had some brass. And these guys are definitely far more dense than these white blocks. So the question is, how can we represent that? And let's take a look at a couple different options here and see if we can come up with the best way to do that. Now, if we look at my options here, first off, you can see that the white block is a bigger volume, just like in reality, okay, compared to the brass. They both had approximately the same mass in this case. They're both about 50 grams. And the number of particles, exactly the same. So this is one way you could represent something with higher densities. The problem is this isn't the most accurate way to do it. The big problem here is that if we were to compare one particle of white block compared to one particle of the brass is per particle heavier. All right, so a better way to represent the brass as being denser but also equal mass would be perhaps to change the actual particles themselves to being, again, they have to be more compact. So let's see if we can't change this. Something like that, right, where there's definitely a difference in, let's just go ahead and make it bigger. There we go, I like that. All right. The spacing in between these particles is less. All right. Let's say that this particle is twice as big or so. It's equal mass. It would weigh the same amount, in other words, but the spacing in between is different. Now, let's go with one more comparison. All right. For the small brass and the large brass. Okay. Now, this large brass is definitely bigger in volume and bigger in mass. However, I want you to take a look at how we can represent these two things with the particle model. Even though this is bigger and heavier, more massive, all right, look at the spacings that we have for these two. They're equal spacing, which means their densities are equal. All right, just because something is heavier does not necessarily make it more dense. All right? So this is how we can represent densities using the particle model. If you got any questions, let me know.